Yes. Okay, so you will not be here. So they can also assist. Okay. 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 Yes. Okay. So I can start, Nkosi? Thank you. Hi, good morning, colleagues. From my side, we had a couple of technical glitches. It's always part of this broadcast and working with programs that you don't know that well as your colleagues. But I hope you can see my picture and that it will be fine for you to see it. All right, a couple of first things that we need to address is, yes, there was a problem with the electronic copy where people mentioned that the Afrikaans and the English is different. So let me explain to you what happened. Is you will see that the paper that the learners received, that is not the case with that paper. There the Afrikaans and English is the same. I'm talking of there was questions where B and D will be different in the multiple choices in Afrikaans and in English. But the paper that the learners wrote, that paper was correct. So that just means that the electronic version that we shared with you was not the final electronic version. So somewhere between us and exams where we submit these documents, changes was made and we did not get the final electronic version back. So we will now apply to them to send us the final correct electronic version. So please, when you look at the exam paper, take the paper copy that your learners have got. That is the one that I will also use for the discussion today. So that's very, very important. Don't work on the electronic one. There will be some problems with the electronic one. All right, then secondly, you will see that your memorandum for today, the marking guideline, yes, we will have some changes. So colleagues, please, when we are done, your marking guideline should look something like what mine are looking here. So yes, you will have notes, you will have other options on it, and don't put a copy of the marking guideline in your file which don't have this notes that you have made. Put the one that you use for marking. That's very important for moderation purposes, that we work like that. So that is that being said. All right, then the corrected paper, in other words, the correct electronic version, is the memorandum that we are going to finalize today, that we will mark accordingly. Those corrected ones will then later be available on the website, and we will also share it through our groups. You must remember that when we work at National, you have up to 3 days to standardize a marking guideline. And then that is the marking guideline that you will see when you start to mark at the end of the year, or when you later on download it from DBE's website. We don't have that luxury of having 3 days to agree on a perfect marking guideline. So today is just the first step to have agreement. This is how we will mark. These options are now options that we will take in consideration. So it's normal to have a marking guideline where changes was made. So having said that, let us just start to look at, I'm not going to go into detail with every calculation, every definition. We picked up that there's no problems when you mark your initial couple of scripts. There we will go quickly over it, and you can always later on also, if you run into a specific problem, liaise with your subject advisor. So let us arrange it like that. All right, I'm going to look at the multiple choices first, and on the multiple choices, we have 3 multiple choices that actually gave us some challenges. All right, so please take note that there is the correct answers for 1.1 it is C, and for 1.6 it is B, and for 1.8 it is D. The other answers is correct, so there's some changes on your memos. So those people that have marked a lot of scripts, you will need to go back and just check these that you correct your marks. That would only be fair to the learners. Let us just quickly look at these three so that we can see if we can find agreement on it. So question 1.1, I think most of you have seen this problem that we have here with this question, and it was two forces, 3 and 5 Newton, and that was given to us, and then it was said that the resultant force is 2 Newton. So in other words then, to get that, it means that they have to be in opposite directions. So the angle between the two forces will then be 180 degrees. So that is number 1.1, and the answer is definitely C. If we go to 1.6, this is a question that I haven't seen it many times that has been asked like this. Be careful with this question. It clearly states, and just ignore what I've drawn there just for a moment. It clearly says here that there's a electric current flowing through a conducting wire XY. So XY is my conducting wire. So now we want to know in what direction will the magnetic field be at point P. So don't now get distracted with this dot there and think that it is the situation where we have the dot in the circle or where we will have the cross in the circle. This is what we use mainly for to draw a conducting wire where they come to the page or out of the page and into the page on the second one. So let's say that my pen is now the conducting wire. I will use my right hand rule, so that will be my wire. My thumb will point to the right because the current is flowing to the right. So my fingers here at the front indicates then that the magnetic field will be into the page. And that is why this answer is B. All right, so this dot here is just a point here that we indicated. It is not that dot inside a circle where it shows that current is flowing out of the page. Current is flowing from left to right. That's why my thumb is left to right. And you can see at the front, my fingers is going into the page. My magnetic field will be into the page. So that is the reasoning in this question to be able to do it. If we can then move on to 1.8. A lovely question where we had a lot of discussions, and I think a lot of you are waiting for this to clarify this question, why we say that the answer is D, and it was also one of the ones on the electronic paper where we said that there might be a problem here, but you will see when you look at the physical paper, Afrikaans and English do look the same. So if we look at this question, remember there's two ways of calculating the brightness of the bulbs. And we are looking at the brightness. How does it compare to the brightness when a switch here is now opened? So in this case, let us look at both ways quickly. The one way would be to say, all right, if I look at this formula, brightness, we look at power. And power can be measured like this, V square over R. So I will have a V over these. There's no internal resistance, so my EMF will also be the same value as what will be the potential difference across all three of these resistors. So in other words, they will have the same potential difference, and that potential difference will be equal to the EMF. And that gives me the brightness before I open S. Now I open S. Now the potential difference across them will still be equal to the EMF. So I will get the very same value there, which is equal to the EMF divided by their resistance that haven't changed. So that is why X and Y will still have the same brightness. Now we can go to look at Ohm's law, where we say, all right, let's say what happens to the current Now, if we look at current, and always I used to, when I work with teachers, tell them, when you have resistors in parallel, this formula that works very nicely to compare brightness. When in series, other ones like the one of I squared R works very nicely for series. But okay, let's have a look at this one. So what happens here is, if I open the switch, it means that my equivalent resistance is now more, because there is less resistors in parallel. All right, I hope that is clear to you. And then, because this resistance is now... Can we just mute that microphone, please? Because this equivalent resistance is now more, it means that my total flowing through this area will now be less. But remember now, the current is divided into only two branches now. And if you go and do the math, then you will see that the current is still the same going through them. I can show you, I actually went and did a calculation for those ones that find this difficult. Yes, the current decreased, but it also went through less branches, so the current actually still stays the same. Let me quickly, because I also feel that this is part of development for us all, you know, to just quickly look at this. So if I look at this question here, I just put three resistors, 3 ohm, 3 ohm, 3 ohm, and I said that my EMF is using this formula. Then the potential difference across each one of them will be 12 volt, and divided by the resistor, I get 48 watt is the power through each one of them, and that is the brightness. All right, now if I want to do the calculation using Ohm's law, I used I calculated what is the equivalent resistance. It was 1 ohm, and then I calculated with Ohm's law, V equals I times R. I calculated the total current, which then worked out at 12 amperes. And then I said, but that current will be divided through 3 branches. So each branch will, and then because they are the same, it will be 4 amperes. Going to this formula here, then it clearly shows me that I square R, if I add put in the 4 square, it gives me 16 multiplied by 3. Again, I get the very same answer using both ways. All right, now I only have 2 resistors. Okay, now for 2 resistors using that formula, I will get the same answer. But for 2 resistors, now if I calculate for 2 resistors the equivalent resistance, it is 1,5 ohm. Now if I calculate my total current, it is now using Ohm's law, 12 divided by 1.5, give me a total current of 8 amperes, which is correct because we said previously the total current was 12, and now with less resistors in parallel, the total current is 8, which shows us that the total current came down. But that total current is now divided into 2 branches, giving me 4 ampere and 4 ampere per branch, which is still the same current as what I got with the 3. So if I put that very same in there, I get the same answer. The brightness for 2 and for 3 remains the same. I want to allude you to the fact, if there was an internal resistance, we would have got totally different answers. But this is the answer we have when the internal resistance can be ignored. The answer is, in other words, the answer is D. It remains the same. If this was too fast and you want me to engage with you later, you are more than welcome to contact me, and we can go through this again in on a one-on-one basis, and I will help you. But please accept now that the answer is definitely D, and mark it as such, colleagues. All right, so that is the issues that we had with the multiple choices, and that was also conveyed to us through our different medias that we have, our WhatsApps and telephone and so on. And thank you for every contribution from a teacher. It helps us to have a memorandum which will be fair, where everybody will be marked the same. So that is the multiple choices. All right, so now I'm going to move on to question 2. There is my question 2. Question 2 was the one on vectors. And on the first one, information was given, calculate the resultant force of those two vectors at 20 Newton to the one direction, and then in the opposite direction at 30 Newton, and north and south. So I think that question we had no complaints, no problems with it. There is your two options that you can mark it with. And we should be fine with that. Just take note that depending on the direction that they've used, we will find that it will either be minus 30, or if they use the other direction, it will be minus 20. So it's 1 mark on each of those correctly added together, and then 1 mark on the final answer with the direction. So that will give you your 3 marks. I think this one will mark quite easily. Going to the next question, which is a definition question. Then on this question, we will mark it as 2 or 0. You will see these days we tend to lean much more towards a 2 or 0 situation for definitions. So be very careful, read carefully. We don't expect every the and or and of to be perfectly there, but there is keywords that we must have there. We need to see that it's a single vector having the same effect as 2 or more vectors together. So that will be the keywords that we will be looking for. If the learners did not write, it's the vector sum of 2 or more vectors. In other words, I mean that for me, the keywords lies in this, where they say we have 2 or more vectors where the resultant vector is that single vector that has the same effect. So this question will be a 2 or a 0. Be very careful. We find a lot of time that this is not marked accurately. Colleagues, you will also see that sometimes we do split it up, and I will discuss that later when we get to this, but this one is a 2 or 0 question. Okay, all right, now we get to question 2.2, and here we had a slight problem, all right, where you will see on the English that although it was said that it's not drawn to scale, a learner might have thought that, oh, but that Y value is not exactly +6. You know, he might have, like me, said, okay, but if I draw a dotted line straight down, the -7 is fine, but this might be a 5 or something like that. So, and if you looked at Afrikaans, the interesting thing is it's much more accurate. So something happened sometimes when you PDF these word files, and then things move slightly. So it's a good chance for us to tell our learners, when they say not drawn to scale, and that is the only values that they give, then you should think, okay, all right, let me use the +6. But we decided, let us have an option here where if a child use something slightly less than 6, let it be 5 or 5.5 or something like that, then we will still work with that. All right. Now that does not influence question 2.2.2, where they had to do a scale drawing. And they had to use the head to tail method. That problem that we have here on drawing, it relates to question 2.2.3, and that is the one that I will really discuss. But let us just go to the scale drawing. If we can look at the scale drawing, if I apply my criteria, the first one is there must be a scale, so that is 1 tick on the scale in there. My second criteria is that there must be a right angle, so I don't expect them to show me the right angle there, but I can see when they draw it if they applied a 90 degrees angle there, and that is my second mark. Then if they're correct with the magnitude and the arrow, they will get a mark for Q, then also a mark for R if that one with arrow and magnitude was drawn correctly. Then look at the resultant. If the resultant, it must be correct with the arrow. So the arrow must be there for the resultant. And then now they need to use their scale to get to something like 6.4. So they will say, easily see it's not 6, it's not 7. When they work back with their scale, and here, let's look at the range, maybe 6.3, 6.4, 6.5, and accept that range there, because it is a drawing and nobody can work perfectly. And the same thing then, the 6 mark is for the direction, which they will measure. And also here, let's look for something between 37 and 39 for that last mark to be quite accurate, because it was a scale, it was not a calculation. So learners using their instruments won't be able to say it's 38.66, although that is the perfect answer. So we will allow 1 degree less, 1 degree more than what we actually expected. I hope that is clear to colleagues. Now we will do the scale drawing, right? And I hope that your learners brought their instruments with them. They should expect that type of question. Moving on to question 2.3 now, where they had to calculate the magnitude of the resultant on. I see some people are saying something here on this question. There was somebody with a sound problem, but it looks like the others found that the sound was okay. I'm also just checking. It looks like my sound is on. Yes, I'm listening.
Yes, this is TV. I have 2 questions now.
Okay.
Yes, question 2.1. Well, how do we deal with a situation where the learner, instead of using north and south, the learner uses down and up? Do we award a mark there?
Okay, that's on question 2.1. Do you agree?
Yes.
TV, yeah. We gave them the directions, you know. So
okay.
So then, what did they use? Just say up or down. Did they use up or down? I could not hear you clearly.
Yes, instead of south there, they use down.
That's fine. That's fine for me. If they use up or down, I don't have a problem. Really, I think it's okay. Okay. So they would have in the answer then said up or down, depending. They would have said down. The answer itself, no? Yes. So they, yeah, I think that's acceptable. Are you happy with that, TV?
Yes, I'm happy. I'm happy too.
Okay.
And then we have another question in our chat.
Yes.
That is from Alicia.
I've seen that one just now.
2.2.
Okay, so a learner have added the 180 degrees here in this question. Eh? So they did not only indicate the 38 or the 37 or the 39, they've added that to 180 degrees. Am I right? Because they wanted to get, no, they've added it to 90s. Sorry, they wanted to get that bearing on that I've shown there. Okay, totally acceptable. So we will accept anything from 37 to 39 degrees plus 90. So that is then a bearing that they've shown there. I think that is fine.
All right.
Yeah.
Okay. No,
Thank you for that. That's very nice. You see, now we have a standardized question and we've done all the options that we might have missed. No problem. Happy everyone there? Okay, question 2 is then finished. Let's go on to, there's other issues that we need to look at that will maybe be more challenging. So let us move on to question 3. I don't think that in our discussions earlier on the various social networks, we did not pick up a lot of problems with question 3. So question 3 was the one where we have this block that is moving horizontally with a constant velocity. So, and there's an applied force of 3.42 Newton on it. And then the first one is Newton's law, which will be a 2 or a 0. I think nobody will have a problem with how we want to address that law. Then the second question was, is there friction? It's just a yes, it's a straightforward, there must be friction. And then the next question is, explain why you are saying there is friction. So I think this is quite clear. We are looking where they say there, the resultant force acting on the system is 0. Because we mentioned that there's a constant velocity. Okay, so I think that is quite easy to understand how we award that mark. And then it says here that if the learner says that that friction must be equal to 3,2, or just that the friction can't be then 0, that will be the second mark that we award there. All right, and then draw a free body diagram. Yes, we know it's going to be in papers from now on, right till the end of grade 12. So let's make sure our learners use acceptable labels. That is very, very important. So let us just look here at our marking criteria, where we said that the following will then apply. 1 mark for each arrow and correct label. So if all the arrows is correct, all the labels is correct, they will get their 4 ticks there, okay? And then now, how do we penalize? If there's no arrows, we penalize once. If there's no dot there, we penalize once. If the space between the dot and if there's a space, we penalize once. So if there's 3 spaces, it still will only be -1. And if a learner uses dotted lines, we also penalize there. So if a learner didn't use, for example, the correct label here, he will lose that mark. Not the correct label there, he will also lose that mark. So the labels need to be correct to get marks at all. But then this is the extra penalization that we do apply. I hope, colleagues, that is quite clear how we mark this question. So we don't penalize for the same mistake more than once. Right, then the last part here was just a calculation where they had to calculate the frictional force. So if you look at that, straightforward, 1 mark for the formula, which is on the data sheet, then 1 mark for each of those substitutions, and then 1 final mark for the answer. So, and while I'm with this question, colleagues, when we moderate, we find the following. We find that teachers sometimes only use ticks, no crosses. You need to indicate if the learner don't get full marks for a question. You need to somewhere indicate with a cross where did he make his mistake. Don't only mark with ticks. That can't be. You need to. It will only be ticks if the learner get 100%. The second thing that I just wanted to stress here is that at the end of question 3, we will normally draw a line there on the right-hand side. And all your ticks, your 4 ticks there, will then correspond to a mark that you will write there of 4 marks. I hope that is quite clear to you. And the same will happen with all the other questions where we will indicate the total per sub-question. The total per sub-question. I'm now doing this as if I'm marking a learner script. Then we will have a line at the top where he wrote question 3. And I will add up all those marks and write that total there. So when I want to get the total of the paper, I'm going to add all these questions that all these marks that I've had per question inside. So again, my subtotal corresponds to my ticks that I made. And I don't only use ticks, I also indicate, and please, when you mark, also make it informative to the learner. If he uses a wrong formula, circle it and write wrong formula, or just I know we're in a hurry to finish, but a paper serves more than a purpose of just giving the answers or getting the total that the learner obtained. All right, having said that, let's move on to question 4. With question 4, there's somebody's video that is on. If you can just take that video off, sir.
Before you move, we have a hand from Aleta.
I see, yeah, she's asking something on we have a question on 3.2. Question on negative marking. Let me just go back to question 3.2. See what is the question there. Just help me. I see somebody's camera is on. If you can just help me to say whose camera is on. I can't see on my screen now, but somebody's got a camera on there, a gentleman. It's got a very good
Mr.
camera.
Oh.
Okay, but okay, all right. 3.2, let us just have a look there. She asked us, is there a question on negative marking for 3.2? 3.2 was just a yes or no if there's a frictional force or not. Yeah, we will apply negative marking here. I mean, there's no way that we can, if he says no, there's no frictional force, yeah, I think they will forfeit this marks as well. I was not the person who set the paper, and please, my colleagues, you are welcome to come in here if you've got a different opinion. I'm just standing in for the examiner and the moderator who can't be available today, but I don't think we never use positive marking in such a case, where if the learner had the wrong answer here, we do positive marking towards this one. Not for this discussion type of question. So in my book, I would say if that is wrong, you will also forfeit the 2 marks of 3.3. I hope, Alicia, that answers your question there. And then somebody asked on 3.4, if a capital letter here is acceptable, a capital W. I think that's what I understand from the question. A capital is not acceptable. It must be a small letter W as far as I know. But again, if somebody has got more information on how they mark it at the end of grade 12, then maybe they can come in. Then there's also a question on what if for applied force they only use a F. I hope I understand that question correct. If they only use an F and not the F with the A or the F with the applied. Colleagues, I think from the examiner and the moderator, this is quite clear that only a F will not be accepted in terms of what I have in front of me. So let's stick to what we have here. This is the acceptable levels for this paper. So I think we should make a point of it that we teach these grade 11s already now the accuracy that is demanded from this. That they can't abbreviate with APP, for example. So in this case, just the F was not accepted. It's not one of my options here. So let's stick with the examiner and the moderator there. I hope that answers your question. Stevie, anything else from your side? You think question 3 is covered?
Marnus?
Yes.
My hand was up there.
Sorry, you can come in, please, Alta.
This side. Question 3.5. I have a learner that took the long way because I so forced him with FNet is MA. She's using FNet is MA as a starter formula. And then for the friction, she substitute in me times N. And then correctly substitute everything and at the end calculate me as 0,07. How do we award marks in this case? I will switch off now.
Alta, you're switching off too quickly. You will have to repeat. Your learner, you say used F net equals M times A. Am I right?
That's right.
Okay,
and then substitute in applied force minus the friction force on the left.
Okay.
And she knows it's a constant velocity, so MA is 0.
I'm with you.
Okay, and then she calculates for the friction me times N.
So she's got 3, she substitutes 3.42 there.
Yeah, that's correct. And then me
there.
times 5 times 9,8.
And then she's got this.
Yeah.
Am I right?
That's right.
Okay, and then she will get the answer because she's still going to calculate that.
She's calculating 5 times 9,8, yes.
Okay.
And
so
then,
yeah, it's easy. You will give a mark for the formula. All right, happy with that?
That's right. Yeah, I just want to know.
Then in this case, I will give a mark for the applied force.
Yeah.
And then I will give a mark for the calculation of the 5 times 9.8, the normal force.
That's
and
right.
Then I will give the last mark for the 0.07, which is my answer. Are you happy with that, Alta?
That's. I just want to know.
We will make sure that we add this as an option. That's interesting. Yes. Are you all?
Marnus?
Okay. Colleagues,
Marnus?
Is there another question?
Yes, just an addition. On the free body diagram, we can accept a capital letter F for the applied force. No? I think it's just a hand side there.
Just say again. I missed that.
On the free body diagram for applied force, we can accept a capital letter F as a symbol for applied force.
So you want me to do this?
Just add capital letter F there as one of the symbols that are acceptable. Thank you.
Okay. Are we using like that in the end of the year in grade 12?
Yes.
We do mark that correctly.
Yes.
Okay. Then I'm happy with that. Remember, I just work on what I received from my examiner and the moderator. Okay. But if you are quite sure,
okay,
then I'm happy with that. Okay. Any objections from any of you there? I know some of you are marking at the end of the year also. We want to align with the way we mark grade 12 already, although this is a grade 11 paper. Everybody happy? No objections? All right, then we can accept it. I don't have a problem. We will add that. Thank you for that, Evie. I think this is great. All right, let's move on to question 4 then. All right, so here I have question 4 in front of us, where it's the 2 blocks. The typical question that we know will also go through right now until the end of grade 12, Newton's second law and those type of questions. So just have a look there. All right, question 4.1.1, I've got it as a definition, which is a 2 or a 0. So that is what I have there. Then let me just move this nicely. That's better. All right, and then 4.1.2, calculate the magnitude of the tension in the blocks for 6 marks. All right, so here we don't want the system method. So we will have block M separate and we will have block N separate. So let's just look at the awarding of marks. 1 mark is given for any one of those 2 formulas there for block M. So if they wrote F net is equals to M times A, that is 1 mark. If they've written already where they've substituted the forces that will give us F net, then it's the same mark. Okay, so we will award 1 mark there. But look carefully, we are not awarding it again for block N. So it will be once only. Okay. Then if we go to the second mark is when we, for block M, we will have the substitution now because we know what is the frictional force. All right. And tension we don't know. Now be careful here. Look here, we've got 1A and for the next block we've got 5A. They need to have both of them correct to get that 1 mark. So it's not a mark on the 1A and another mark on the 5A. If we can see both of them, that will give you your third mark. Then for block N, we don't award again for formulas because the very same type of formula was awarded already. But for the substitution here, where they've calculated that gravitational force, there we will give a mark, and then of course for the minus T. Now we don't award any marks because using these formulas we are going to be able to calculate now combining these 2, we will find the acceleration. All right. Now using the acceleration now in any one of the 2 formulas, then we can calculate. So if they substitute for that substitution of that acceleration in 1 or the substitution in equation 2, there we will then award those marks. All right, that is 1 mark there, and then on my final answer of unit is the last mark. Now let's say a learner made a mistake here in calculating the acceleration. So he found some acceleration here using things that he might have lost marks earlier, or he simply we did this part, he made a mistake. You see this part where we combine the 2, according to our marking guideline, doesn't constitute any marks. So getting the wrong answer there, but still substituting that wrong answer in there, in any one of the 2 equations, will give them that substitution mark. Let's just be clear on that. Okay, but of course now if he miscalculated that A, and he's still going to forfeit the final answer. So that's where he will be penalized if he couldn't do that part properly. He will then be penalized in the answer. I hope that is clear, colleagues. So it's formula, it is then substitution, those 2 marks there, 1 mark for the 1A and the 5A, and then they need to find the acceleration, but that doesn't count marks. If they made a mistake in that acceleration, they will be penalized in the final answer. So we can still accept if they substitute that wrong acceleration. That is how we will mark 4.1.2. And of course, there's 2 options. We have the option where we chose to the right as positive, and we have the option where we use to the left as positive. I just showed here again, the 1A and the 5A is only 1 mark, but the rest of the marks we awarded exactly the same as discussed just now. So I hope that calculation is quite clear. Moving on to question 4.1.3. There's question 4.1.3. Then you will see there it's a question where the learner has to have an argument now that we've got a statement and they need to say if the learner is correct, that will be 1 mark, and then for 3 marks they have to explain, and they used to have use a relevant physics law. Now when learners get a question like this, you need to tell your learners that they should mention that law that they are applying, because that will also be a mark. So let's just have a look at the memorandum here, our marking guideline. All right, so they get 1 mark when they say no, the statement. And of course now, if a learner say yes, it is true, then they will forfeit all 4 of the marks, because there's no way that they can reason correct after that. But 1 mark on the no, then we want another mark if they mention Newton's 3rd law, because that is what is applied in the 4th mark. So we are looking for something where the learner, and you need to read carefully here, because the learner might use different language, but we want to have the right concept where they must say that the string have a force on the object, on M or on N, and then the object have a force on the string. So that is applying Newton's 3rd law. So that is my 3rd mark. Now comparing the force on N with the force on M is not according to Newton's 3rd law. So that will be my 4th mark, that they cannot cancel out one another, as this law don't apply when it's 2 different bodies. So I think this is quite clear, but I think if you're in a hurry, you're easily going to just give a cross and a 0. So just give this wording and a descriptive type of question some of your time to read carefully and see if the learner understands the concept. Okay, so I hope this is clear. All right, then question 4.2 is the one where the blocks falls off the table. And I know there was a couple of people that asked about, but what we did not mention here, that there is no air friction. Now, yes, we did not mention that, but we also know that air friction only becomes a factor once a body goes close to terminal velocity, when it reaches terminal velocity. Now, when something falls off the table, it will be so far from terminal velocity. But still, if you get that, you get that learner who's a 90% plus learner, and they might now say, okay, I'm going to answer this question now, where I look at if there is air resistance, and then also you will answer the question without air resistance. So then we are only interested in the part where they look at without air resistance, because we are in our syllabus not applying air resistance except if it is said specifically, and you will never see that. So I think that will clear up the issue of, but the air resistance was not mentioned. If a learner then doubts, let him try and answer it for both scenarios. You can't just leave it out and say, no, I can't answer it because it was not mentioned. There is 2 scenarios possible, and we will mark the scenario without air resistance. Okay, so it's quite straightforward that both of them will have the same acceleration because they both experience gravitational acceleration. Maybe here you will find that they will use this formula. If they use this formula to show that in this case that the mass of the objects don't play a role in the acceleration that they experience. So just look carefully for that second mark. I would like to think that if a learner writes that the mass of the bodies don't influence the acceleration, then that can also be accepted. But instead of just saying they will have the same gravitational acceleration, they will have the same acceleration due to gravity. Just be careful with that one, but I think if they say something like mass don't play a role, and especially if they can even say that formula and explain why they get to that point. So yeah, that is question 4.2. So I'm done with question 4. I don't see in the chat any questions. I don't see any hands raised. So it looks like this one you did not experience too much problems when you marked it. So let us move on to question 5. Question 5 was the question, here we look at the satellite, which is in orbit, this 3.6 to the multiplied by 10 to the power 7 meters above the Earth's surface. All right, 5.1.2, colleagues, here with 5.1, we say it's a 2 or a 0. It's or a 0. Now let's look at, now we have to look at the gravitational force exerted by the Earth on the satellite. All right, to calculate the gravitational force exerted by the Earth on the satellite. So there is my formula, 1 mark for the formula. All right, and then it's 1 mark for the substitution at the top in each one of those, the mass and as well as G. Then they had to add the orbit, the distance to the orbit, as well as the radius of the Earth together. So that is 1 mark for adding it together, and then they had to square it. So that will be the second mark. And then the fifth mark will be on the answer. Now, this answer should actually have a direction of down, because the question was calculate the gravitational force exerted by the Earth on the satellite, not the magnitude of the force, but let's stay with what the examiner and the moderator expected here. They did not say that down, because we know that force from the Earth will be having a direction as well. But they did not award a mark on the down, so we will leave that. But maybe it's something in your discussions that you can make a learner aware that the next examiner might have given that mark as well for the word down that was expected there. So we will stick with this way that it was suggested to be marked. That is their prerogative to decide how they want to award those marks. I hope this is clear. 5.2, then 5.3, straightforward calculation of the acceleration. All right, and 1 for the formula, 1 for substitution, 1 for the answer with the correct unit. And we use positive marking from this question. So please just be careful. They can get full marks for this question if they use that incorrect answer that they obtained there. So you will need to also give it the due time using your calculator to see if that answer is correct. They can get 3 out of 3 if 5.2 it was not 111.04 that they used there. Okay, so that is question 5. I see here we have a question with question 5. A question on question 5, if they use 5.3, they use G equals, so the question here is what if they use this? If they use G equals GM over R square. Yeah, I assume, Alicia, I said you that asked the question.
Yes,
so if they put in the correct values, they will get the correct answer. Am I right?
Yes, they will.
Yeah. So,
just a question on the substitution of the distance between the centers. So if they...
Sorry, we've lost sound. Just say again, Alicia, please.
Okay. So in the substitution for the distance between the two objects, if they didn't add them at 5.2, do I do positive marking with that as well?
Yes,
Okay.
let's do that. Yes, let's apply the very same. So if they use this formula, then we will also still award the marks. I'm
Right.
quite happy with that. Okay.
Thanks.
So it will be 1 mark on the formula, and then it will be 1 mark for substitution. Okay, can you give me the value of R that they must substitute there, please? Do you have that on hand, or I shall work
No,
it
I
out
just
later?
used the top one.
Okay, that very same one there where they
That
add it
very same
together.
one.
Am I right? Okay, and then it will be 1 mark on the answer with the unit.
Perfect.
Okay, thank you for that. Yes, that's brilliant. Okay, I see Alta, your hand is up.
Yes, Marnus, I'm just a bit unclear. If the learners didn't add the height above of the satellite above
On
the
this
ground, but
question
only
here.
5.2, yes. If they only have 3,6 times 10 to the power of 7, do we award a mark for that of the 2 marks or not?
Yeah, if they did not, my feeling is, and again, you guys that's maybe more experienced markers can help me. I think if they did not add it, but they still square it, we can award 1 of the 2, but they will definitely lose the answer also. So then a learner can get 3 out of 5. He will have 1 for the correct formula, 1 for the top substitution, 1 for squaring, whatever they have there, but they will lose, they did not add and they don't have the right answer, 3 out of 5. Are you happy with that, Alta? Or do you feel we should penalize them with 3 marks if they did not add the 2 together?
No, I would agree with giving a mark on the 3,6.
All right, colleagues, I will just repeat so that we are all on the same page. Let's say a learner did not add the radius of the Earth. So then he will only have this 6.38, if I'm correct. Let me just check on the question. Yeah, the 6.3.10 to the power 7. So he will only have that, but he needs to square it. So if he have only that and he's still squaring it, we will award 1 of the 2 marks on the square of that. And then, of course, he will lose also the mark for the final answer. That will give him 3 out of 5. Now, let's play devil's advocate. He's got the 3.6 times 10 to the power 7, but he did not square it. So he will lose the 2 marks because he did not square. He did not add the radius, 2 marks gone. Wrong answer, 3 marks gone. I think that shows the progression in marking for the different mistakes. Alta, happy with that?
Yes, thank you, Marnus.
Okay, you still have your hand raised. Is there another question?
Oh, sorry, old hand.
Okay, no problem. Okay, so we are covered there with question 5. Let's move on then to question 6. Yes, we will maybe spend a bit of time on question 6. And we had a slight problem here where, before I go into the answers, you see here we have the 2 charges and then we let them touch. And then we had another drawing where we then had those charges given there, okay, which then might lead to confusion. Now, normally what we will do is, if there was one drawing like this, we would not have a problem if the charges was up there and the other one was down here, and we even say they would touch and place back to the original positions. But because there was 2 drawings here, 2 graphical representations, now we suggested that we look at both of them. All right, so we will get to that now in the memorandum, and you will see mine, I've corrected it already, but you won't have this one now, but let's go from here. All right, first question here is the sphere experiencing a force to the left or to the right? I think there it is straightforward. I just want to get to 6.1.1. That one is straightforward to the left, no problem. Then the second question is about was electrons removed or transferred? No problem, it was removed. Okay, so learners will be happy with that answer there. All right, then we get to they are now allowed to touch one another, and and then they are separated again. Okay, so they are getting contact and then they are separated. So no problem there. We have given them the two charges, and this is the way we mark it. All right, so they have to use the negative and the positive in this case, and then we get the final answer there. So that is how they decided to award the 3 marks. No problem there. Then if you go to 6.2, I'm just going to turn over 6.2. They ask state Coulomb's law. All right. Now, asking to state Coulomb's law, you can check here. It's the first time now that we've decided to answer this question, where we can award 0, 1, or 2, because it's clearly indicated here that the 1 tick will be where they say directly proportional to the product of the charges, and the second mark is inversely proportional to the square of the distance between them. So this definition is broken into 2 parts, and you will look for the 2 parts, and here a learner can obtain 1 out of 2. It's the first time now that we allow that for a definition. We seldomly do it, but for definitions like this, it works quite nicely. All right, now we're going to move on to question 6.2.2, where they ask, draw a vector diagram and show the electrostatic forces, and the net force experienced by Q and R. Now, I just want to write down here that learners might have used the calculated total that they've calculated here. Let me just see. The answer was minus 1 times 10 to the power minus 9. So it's minus 1 times 10 to the power minus 9 and minus 1 times 10 to the power minus 9. So we've got 2 scenarios now for this question. One where you will need to look if the learners worked with these 2 equal charges, or if the learners have worked with the minus 6 and the plus 4. So let me show you what it will look like now. And maybe you would like to make a note, but you're going to get this memorandum still during the day, where we've corrected everything now that we have decided upon. Okay, so if they use option 1, now option 1 was where they've worked with the minus 1 and the minus 1, then this is what it will look like, the vector drawing. Right, now let us just look at the criteria of marking for that one. 1 mark for the force that is indicated there. Okay, because it will be repulsion, because both of them are negatively charged. So it will experience a force to the right. And then it will experience, because it's negative and this one is positive, it will be attraction. So that is the second mark, which will be this one here. And then the third mark will be where they will show that the net force then will be somewhere in that direction. We don't expect it to be on scale or anything. So the resultant vector will be somewhere in between those 2 vectors. So that is the scenario where they used minus 1, okay, times 10 to the power minus 9. Now, if a learner stick to those that were given, then of course this direction of the force between the 2 of them will be to the left. So that is where we will now award that mark, because it's to the left. Now this one and this one is positive. All right, so it will be repulsion. So that is why now that force is there upwards. And the third one is now the net force will be somewhere in between those 2, depending on how long the arrows are. But we are only looking for that. So yes, just be careful. It might be one of those 2. If they use the equal charges after they've touched, it will be option 1. If they used equal charges, the charges as provided there, it will be option 2. All right. So that is the way that you need to look at it. Be careful. You might need to go back and see how you're going to give these marks. All right. Now for the next question. where the learners had to calculate the net electrostatic force. Here was a typing error as well. That S should have been an R. And there it's an R on the drawing as well. So we did look at, would the learner be in a position to see that there's a typing error here? And were the learner disadvantaged? Now, this is a typical one where the learner might have asked you in the exam room, and the feeling on the majority of people was that the learner would have understood, looking even at the previous question, that yes, that is a typing error, and you will still be able to understand from, because the drawing was giving, I want the net force on Q, and there is the two charges. So either the learner again now used the -1 and the -1, or they've used the -6 and the +4 and the +8. So two scenarios here that we will accept. And you will see that we have both options now. And I think that will now be fair towards the learners. So here is option 1. Option 1, colleagues, is where they used the 1 × 10⁻⁹. Now remember, in this equation, we don't put the -1 in there. We use positive values there, because at the end we will be able to say what will be the direction. So 1 mark on the formula, 1 mark on all of the substitutions. All right, then they're going to do, that was now between the two charges that we have there. And then they will do a second calculation for the next force. You can see no direction was expected here because there's no marks awarded onto that. No mark now this time for the formula, but 1 mark for the substitution. So we are on a total of 3 marks up to here. Now, they need to use these answers now in the applying Pythagoras. So 1 mark if they use those and they square them according to that formula. So even if a learner got the wrong answer here, but he did that part correctly, he will get that mark. If a learner substituted correctly there, in other words, he got the wrong answer there, up to here, he will still have full marks. He will still have now a total of 4 marks. But now, because he made a mistake in either one of the two there, he will forfeit that final mark there for the answer. So then he will have 4 out of 5. But if he worked perfectly, he will have 5, and now he's finished with the magnitude. And then the last 2 marks is on calculating the direction, and the examiner decided here to work now. This is now if they use trigonometry, né? So 1 mark on using the different components that they have, and then they will get the angle. And we accept both, that they can use it to the horizontal or they can indicate it to the vertical. So that is acceptable. We don't worry too much about adding 90 or not adding 90 or adding 270. There was no marks awarded onto that. But if they wanted to represent it in a bearing, then you can just look at that bearing and also accept the bearing. But I think you will be able to award these marks already before they get to the bearing of adding the 90 or adding the 270 degrees. All right. So let me just finish. I see we have a hand. Let me just finish with the second option, and then we will go back to questions, because then we are mostly done with this question. Now, the second option is now where the learners use the -6 and the +4. So you will see that here we have the 6 and the 4. We use positive there, and the learner then can get the same 2 marks as in the previous one. Now it's between the 4 and the 8 is my second option, 4, 8, and they will get a mark there. Then if they use those answers into Pythagoras, same mark there, getting the answer there, same mark, calculating the angle, 1 mark for that angle. And if they want to present it in the bearing, fine, but no marks on that. But you should be able to award the marks before they get to that. I just want to say one thing. You add the, let's go back. If a learner do add the negative in here, let's say -1 and -1 in there. As far as I know, and here the senior markers can come in again and just help me a bit. As far as I know, they will then forfeit that mark. Okay, because we have agreement that we only substitute positive values there. Senior markers can maybe give me guidance here as well. So then he will not get that mark. All right, Marisa, over to you. I see your hand is up. And then I will look at the questions. I see there's a question also around 6.2.2. Marisa?
Hallo Marnus, ek het 'n vraag rondom vraag 6.1.3. Op die Engelse vraestel sê hulle calculate the magnitude of the net charge, waar hulle in die Afrikaanse vraestel verwys hulle na die lading na kontak. So ek vra net of ons daar by 6.1.3 die Engelse vraestel net anders dalk kan benader.
Kom ons kyk dit gou 6.1.3 sê jy, nee, 6.1.3. Let us just have a look. You agree that, are you happy with the English?
The English, I disagree with the English. The English says 6.1.3, calculate the magnitude of the net charge, not the new charge.
Yeah, and I see even here on the memos he's got net charge, nee.
Yeah. And net charge, as if just correct me if I'm wrong, but it is the addition then of the two charges, which will then result in a -2 charge.
Sure. I must be honest with you, I'm not sure here.
Because they say even after separation, the net charge will still remain the same. Before contact, the net charge is going to be -2, and after contact, it is also going to be -2 because both charges will have a charge of -1.
Hear what you say, to get net charge, you just add the two together.
Yeah, the sum of the two.
Okay, okay. To get to that net charge, where you want to add them together, do you agree they still had to do this calculation? Because they were in contact.
Yes, they were in contact, but I agreed. I don't think that it is necessary because you know that before contact and regardless of if it's going to be after contact, the charges are still going to remain the same. That is then how we get to the new charge.
So you want us to say for the English learners that the net charge will be equal to, and then we're going to use 6.6 will be -6 times 10 to the power -9 plus 4 times 10 to the power -9, giving me an answer of -2 times 10 to the power -9. Are you happy with that? Cool.
Yes, I think it was a bit confusing because some of the learners I saw on my papers stated, even though because they focused on the word separated, they calculated the new charge, and then some of the learners focused on the fact that they asked the net charge.
All right. I'm reluctant to make a ruling on this. I'm really, and I'm now the person who's sitting here discussing this. I clearly think it's a typing error, that it should have said calculate the new charge, and not the net charge. So I don't know what to say to you. I must be honest. On the one hand, I can say, all right, we can award marks still here, but how do I get to 3 marks? Because for the Afrikaans learners, it's fine. People can mark the Afrikaans question. We can award a mark if they indicated the positive and the negative, and we can award a mark if they substituted correctly, and then we can award a mark on the answer. All right, and then if they did that, we can mark it. If the learner read it as new, the new charge, we can still for English learners award that. For the Afrikaans learners, then it will only be that one because the right question was asked there. And for the Afrikaans learners, we will just use maybe something like this, Q neat, which goes with Afrikaans and not net. Are you all happy with that? If we accept something like net because of the word that in the question was said, calculate the net charge. Any inputs from the floor?
Ek is happy, dankie Marnus.
All right. I will discuss this question still with the examiner, and maybe we will have a different final ruling. I'm not sure, but we want actually to leave here and decide how to mark this paper. Alta, I see your hand. Input from you?
Yes, Marnus, I've been looking at what the children understood from it. They all answered the first part. So they divided by 2. I haven't gotten anyone.
So this will be an exceptional answer. Do you agree?
Yeah, but it is a correct one if I understand.
Okay, so we will add it there as an option. We will do that, but I think we'll seldomly find a learner who read it like that. But those learners are actually well taught. Any other comments? Thank you for that, Alta. So you are quite happy with that? I see there's one more person who's got a question. Oh, I see Alicia asked here, if the learners in this question did a head to tail diagram. I just want to go back to this one. 6.2. In this diagram. Alicia, if they did a head to tail, I'm happy. I'm happy. I hope you are also happy. So if the learners, in other words, did this for option 1, and that will be FPQ, and then down will be FRQ, all right, and then they've indicated that that will be FNet. All right, then I will be happy to award the 3 marks, and then we do the same thing for the other option. Okay, head to tail, because I'm quite sure in the question it was not said that the vector diagram should be tail to tail or like a free body diagram or something, just a vector diagram, so both is acceptable. Thank you for that, Alicia. Well done. I think Alicia will set our next paper, common paper for us. I see she thinks with all these little angles. But thank you, I really appreciate it. Everybody happy with question 6? Let's move on to one that's had a little bit more discussion to it, but I think you will be happy how we decided to mark it. This is question 7, all right, which is the Faraday type question. All right, 7.1.1, straightforward. It's a 2 or a 0. That was Faraday's law. And then 7.1.2, it says explain the reading on the galvanometer for 3 marks. So we are looking for 3 things here. We are looking for the following. We are looking that when it enters the coil, the galvanometer will show us a reading that will reach a maximum at some stage. And then we were looking for when it stops. I think it says here when the magnet is inside, but it's important to say when it actually stops, then the galvanometer will have no reading. It stops at the point when I don't push it in any further. I'm now going to pull it out. Then it will have no reading. That's the second mark. And then what we are looking for, when the magnet leaves the coil, we will have a reading in the opposite direction. So I think if you look for those concepts there, that it will give a reading as it enters, and it will reach a certain maximum, 1 mark. Then when it stops, second mark. When it leaves the coil, we will get a reading in the opposite direction. That is our 3 marks. Then 7.1.3, 7.2.1 and 7.2.2, we decided to take all of them out. All right, we decided to take them out. And the reason here for this one to take this one out was just because we should have asked through the galvanometer, or we should have asked through this coil. So the question, the learner could reason both ways. So there is no clear answer to 7.1.3. So we took that question out, and then with question 7.2.1 and 2.2, we also took them out because we would have to use Fleming's rule here to decide the direction of the induced current. So which is actually grade 12 work. We know there is a way that you can do it with your palm and something like that, but we looked through all the documentation like exam frameworks and our ATPs, and we decided let's not be unfair towards a learner, so we will not mark those 3 marks. We will not award the 3 marks. The learners will not get that question. So yes, that it will be out of less. The total will be out of less. I hope all of you are happy with that. Then I need to clarify one thing with this question. I was one of the persons who thought that the calculation of the induced EMF is out. Colleagues, if you look at the ATP, I missed it on the second page. It states there that the learners must now be able to do the calculation. So if you were one of the people like me who missed that, they must be able to do the calculation of the EMF. Please go and readdress that with your learners, because they will see it at the end of the year in the final paper. That might be a national paper. Calculations is in. It is part of the syllabus. So, but for this paper, this is how we will answer this question. We will not mark these 3 questions. And I see that, Joseph, you gave us a comment there on 6.1.3. Thank you for that. I think it was then sorted. I see there's a question 7.1.2. What if the learner gives the direction of the deflection? Left for entering or right when the magnet leaves the coil? Okay, 7.1.2. We don't mind if they talk about going to the left, going to the right, as long as they indicate that different directions, we will have a different galvanometer reading, so that the galvano will be different. So we will have one reading when it enters, and we will have a reading in the opposite direction when it leaves the coil. So that for me, I hope that answers that your comment there with 7.1.2. I know you're going to ask me something like, but what if they don't answer here that it will reach a maximum? Maybe the first mark there as it enters the coil. You will get one reading. I think the learners need to understand that in order for the magnet to stop, and when we will have no reading on the galvanometer, then it will have to reach a certain maximum in the one direction. So I think that should not be a problem. Okay, but I see we've got one more hand. Alta?
Yes, Marnus, it's about the maximum, because if we move the magnet, for example, faster, you are going to reach a bigger maximum. So I have a problem with using the word maximum. I would rather just have us to say that it deviates to a side and then to the opposite side than using the word maximum. But I will listen to what your reasoning is.
Yeah.
Also.
Okay, thank you for that, Alta. No, look, then we're going to award the same thing twice. If we say in the one direction we will get a reading, and the other direction we will get a reading, that's already the 3rd mark. But in order for it to stop, it means that we have to slow down, which will in any case indicate that we will have a certain maximum reading in a certain direction, and so let's stay with that. I know now we are making that a lot of learners is going to lose this mark, but we can't award 3 marks. 2 marks on the same thing. So I think we did discuss this yesterday when I spoke to the examiner, and they were quite happy with that. Is the way we should award marks. So let's stick to that, please. Okay, that is question 7, colleagues. Let's move on to question 8. Question 8 was the question on The practical, all right, we did not experience a lot of problems with this question. Let us just look at some of the marking guidelines for this question and what you might have found and how to mark it and things like that. I think questions 8.1.1 quite clear how our marking criteria is. They need to mention the dependent and independent variable. It must be a question and it can't have a yes or a no answer. So that is quite clear. Now 8.1.2, they were giving these values and they had to draw on the graph paper, they had to draw a graph. So there is the graph. What we find is that learners changed axes. They did not put the potential difference on the x-axis and the current on the y-axis. That's the type of thing. And of course, you will find plotting, scaling, those kind of problems you will find there with the learners. But right, let's have a look at how we award criteria. If there's a heading, what they are drawing, 1 mark. I think that's quite clear. If the axes are labeled, even if they are swapped, they will get the 2nd mark. That for me is fine. If coordinates are plotted correctly, 2 of them, they will get a mark. If the coordinates or if 3 of them are correctly plotted, they will get the marks. If they have the best straight line through all of them and starting at 0, they will get the 5th mark. So if I understand this marking criteria correctly, if a learner swapped the axes, they will still get 5 out of 5 if they could plot the correct values next to the correct in terms of potential difference and current. I don't see a place where, because it's specifically mentioned, even if they are swapped. So remember, correctly plotted means if I have a value for potential difference of 3, now potential difference, if I swapped, it will still be on 3, so it's correctly plotted. The axis was just swapped. So in this case then, 5 out of 5 if they have swapped the axes, because we just wanted to see the plotting and from 0 and scaling and that kind of thing. But if the learner had problems with scaling, then they will start to lose marks here with 2 coordinates or 3 coordinates out of the 5 that they couldn't plot correctly. So I think that is quite clear how we mark that one. All right, then 8.1.3, they had to calculate the gradient. On the memo, the original memo that you received, there was a problem. This was swapped. So you got an answer, I think, of 2, if I remember correctly. All right, just make sure they can use any of the values. So if I look at my table, I've used those values there. So current, it's 3,75 and 3. So that will be on my y-axis was current, 3.75 minus 3. So I've used these two marks on my graph. There's the y-axis. I've used those 2 dots, but they could have used any others. And then I've used the 7.5 and the 6. So I just swapped them around, and then my answer is 0.5 per ohm. All right. So now what we need to discuss is what if a learner has swapped the axes and then they calculate the gradient now. All right, so if a learner then has swapped the axes and they've calculated the gradient, that means that they will then have gradient is equal to delta V over delta I. That is if they have swapped it. And then we will have 7,5 minus 6 over 3,75 minus 3. And now we will get an answer of 2, and it will be ohm. Right, so how will we award marks? Because we need to work from that graphs, from the graph that he have. Even if he made a lot of mistakes, he can still get marks here. So we will have to work with the graph that they have. So we will give 1 mark there, we will give the marks there and there for the correct substitutions, and we will give our answer mark there. So that is if swapped. Okay, I hope that is, colleagues are happy with that. We don't have much of a choice here because we decided to allow swapping. Well, even if it's swapped, we still work with that graph. So we will give them the marks. I see you typed it already, and I've got it covered now. I think you will be fine. Right then, 8.2.1. It's a 2 or a 0. I think that is quite clear, 8.2.1. And then we had no problems in terms of the calculations after that. Formula, substitution, answer with unit. Formula, substitution, answer with unit. And then with 8.2.4, they first had to calculate the potential difference. That's 1 mark on that calculation. Then it is not again on the formula because we have awarded that very same formula earlier. And then it is for the substitution and the answer. So also that, no problems. Nobody indicated that they had a problem with that question there. All right. Moving then on to, now we're going to calculate 8.2.5. Let me just turn my page here. 8.2.5, the resistance is now calculated. All right. I think this will also, no problems with this calculation. There's 2 options. You might even discover that different options. We work here with positive marking, so please just look, you might have different values that is still acceptable. So just work with those values that the learners got. No problem there. All right, again, positive marking, 8.2.6. Nothing on the formula, it's only substitution and answer that they've decided to give on values there too. So that is question 8. I think it will not be a problem. We haven't received any information from you that it might be a problem. Question 9. Question 9 is our first chemistry question. It's a question on ammonia. All right, straightforward. The number of valence electrons is 5. The Lewis structure. Look at your criteria, colleagues, there for marking of the Lewis structure. We need to be careful with that. They need to indicate the lone pair for 1 mark, and if they indicated the shared electrons between the nitrogen and the hydrogen, they will get 2 marks. That will give them the 3. The shape is quite clear there. Then we had quite a discussion around 9.4, where 9.4 explain why it doesn't have a trigonal planar shape. Now, trigonal planar shape is not currently in the syllabus, but the learners should know that it's got a pyramidal shape, which I did answer there in 9.3. So that part is not a problem. Why does it have a pyramidal shape? Now, we can reason that learners, that it might be part of the syllabus that is not included, but we had a lengthy discussion. We looked again at everything, and then we just decided to change the memorandum. So this is a change from the one that you have received, where we say we will award 2 marks if the learner says the central atom has got a lone pair, and that is the reason why it has that shape. Ammonia as a molecule is one of those where we look at the dative covalent bonding, so the learners should be very well aware of the influence of that lone pair. So the shape is directly linked to that lone pair on the central atom, 2 or 0. That was the discussion between me and the examiner and the moderator. And then there's a second option there where they can also give you the correct explanation, where they then mention the whole thing of there's the lone pair and the shared electrons, that there's forces and they repel and whatever, and then we get that shape. All right, so that is the way we mark 9.4. We just look for mentioning lone pair on the central atom. So if they use the word lone pair there, you are fine. Okay, 9.5, is it polar or non-polar? That is a straightforward question. 9.6, refer now to electronegativity and explain your answer why it is polar. So here, let us just have a look at this question, 9.6. We are looking for, there is an electronegativity difference between the nitrogen and the hydrogen. All right, so that they need to indicate that. Or they could have said that the electron is not shared equally. That is one mark. We are looking for something where they say, they can say because of the electronegativity difference, the one side is positive, the other one negative, but they need to say that there is a difference between the two atoms. Then for the second mark, now they have to say that the one side is slightly more positive, the other side is slightly more negative. They can say it in words like there will be dipoles. They might even say the shape allows it now to have dipoles. So we know that when we discuss the dipole nature of a molecule, we look at two things. There has to be a difference in electronegativity as well as the shape that allows it to have dipoles. So we are looking for those two areas. You will need to read this question quite carefully. Then I hope that my explanation now shows you what to look for to be able to award marks. Right, 9.7 is the dative covalent bond question. Here we are looking for the learners that needs to say that there's a lone pair available on the nitrogen. Then you will see when you read through this, that is what you will find. And it's a bond between that lone pair and the hydrogen ion. So just be very careful also here. Read that you find those two things. That a dative covalent bond is one atom shares its lone pair with an ion. So that is what we are looking for. So I hope that will help you to understand how we award marks with the dative covalent bond. Just read carefully there. We are looking for those key elements in those questions. Right, now we've got a question here. 9.6, do we use negative marking from 9.5? So if a learner has got 9.5 wrong, he will automatically then have 9.6 wrong as well. We don't do positive marking, so that will be negative marking from there. All right. I think that answers your question there, sir. I'm not sure if it's a gentleman or a lady. Let me see, there's another comment. Okay, let me go again through, I think we are saying we are looking at this question here from the polar. He said, let us just rethink. Look, it's polar because it's got a positive and a negative. So if the learner says just the word, it's got dipoles, I think just saying dipoles will not be acceptable. It's polar because it's got dipoles, but the one is positive, the other one is negative. That's why there's a tick on positive and negative sides. I hope that helps you a little bit to understand that a little bit better. Okay, I hope that helps you saying, let us rethink how we award. So that is one of the 2 marks. Then the other one will be there is a electronegativity difference between these atoms. So electrons is not shared equally. I hope that helped, that I quickly just revisited that question. All right, question 10. We've got 7 minutes to wrap up. On question 10 was the question on the melting point and the boiling point. All right, no problem with the definition. It's a 2 or a 0. It's a 2 or a 0 on that definition. Okay, and then 10.2 was the question where they had to explain the difference in the intermolecular forces and between that and interatomic forces. That one I think is quite clear. Intermolecular forces are between the molecules. Interatomic forces are between the atoms. Okay, so I think that is quite clear how to mark that one. Then 10.3, colleagues, we decided to take 10.3 out because a possible answer is that no one of these substances will be a liquid. But we felt, let us not be unfair towards learners. Normally in a question like this, you will have answer coming from the available options. So we felt that it's not fair. So that is the 4th mark that we are going to take out. 10.4, now they need to refer to intermolecular forces and they have to explain why the one boiling point is more than the other boiling point. For 4 marks, I think this table is quite clear in how we mark it. We will be looking where they have to identify the bonds or the forces. The second one will be to compare, so this mark will be this or that side. Any one of the two, if they say the hydrogen bond is stronger, it's fine, or if they say the dipole is weaker, that's fine. So that is an or between those two for that 1 mark. And then they need to comment on the energy. So they need to, it's again an or, they will either say less energy is needed to overcome the bonds for dipole forces, or they will say more energy is needed. That is an or for that mark. And then the last mark, yeah, that is the 4th mark that I've discussed there. I think this table is quite nice, the way they put it there. It's easy to mark and to understand where to award marks. Right, then question 10.5 is where the sodium is dissolved into water. All right, name the intermolecular force, that is fine. It's an ion dipole force, according to our memo, there it is. All right, and then we've decided to take out, that is our 5th mark. So we've decided to take out 10.5.2 because it's actually very interesting. We can't generalize and say that hydrogen bonds are always the strongest. So in this case, it's interesting. We did a search, and it seems like it even raises slightly the boiling point. So we decided to take that question out. We felt it might be an unfair question, so that's the 5th mark that's out. And then the last question was refer to the type of intermolecular forces and energy and explain the difference between bromine and hydrogen chloride boiling points. All right, so there again, same type of table, makes it easy to award marks. We give a mark on the induced dipole forces. We don't give a mark again on the dipole because we've done it in the previous table. So that is 1 mark there, specifically for the induced dipole forces. 1 mark, it's got a higher molecular mass, or it's got stronger intermolecular forces, and more energy is needed to overcome the forces. So that is the 4 marks, but they can go here towards an or, where they can say that one will have a lower molecular mass, it will have weaker intermolecular forces, and less energy will be needed to overcome the bonds. So to overcome the molecular forces. So I hope colleagues are happy with the way we are marking this paper. You will always find that people teach things differently, but you can find a way of marking it. And then lastly, our total will now be 145 for this paper. So if somebody still marks out of 150 when we do moderation, we know that they did not attend the memo discussion, and then remarking will have to be expected of all the scripts. So it's very important, these things. It's valued very highly. I hope you are happy with the explanations that I've given to difficult concepts like the electricity ones. I hope that is cleared and that the way we want to mark that I paid justice to the examiner and the moderator. I tried my best. And you were very kind to me with the way that you did not get cross in some of my decisions and some of the discussions. So thank you very much for that. Is there anybody who wants to add a question or anything that you would like to add? For my colleagues, Stevie, you guys, Nongwaku, any one of you who wants to add something? Are we in the clear? And we will try to do the amendments to the memo and get it out to you as soon as possible electronically. We don't know when we will get the electronic paper. So I just remind you again, colleagues, work with the one that the learners received. That is our official paper, not the electronic one. Okay. If there's no other questions, then colleagues, I will greet you and enjoy the marking if it's possible. Take it with a cup of warm hot chocolate or a coffee and a chocolate, and it might make you feel better. And all of the best. We will see you again. There's a hand that came up just now. Okay, somebody there?
Yes, yes, Dr. Thank you. We actually just posted a question for that very last one.
Okay.
Will it be acceptable if we say between the bromine molecules we have the London forces?
Yeah, that is, your London force is perfect. Yes, thank you. Yeah, I missed that. I will write it in on my one that I will submit to the examiner. London is acceptable, 100%.
Yeah, kindly bring it down again, that paper, so that I can make a further argument.
Okay.
Then if we have the London and then dipole for HCl, now in terms of the strength, things change, because now between the HCl molecules, we'll have slightly stronger forces.
Yeah, so this is wrong, eh?
Yes, yeah, it will be wrong.
It must just be this way around. How did this go through? I did not pay nice attention to this question. Let us go back to the question. Let us go back.
No, Minir, I think your argument in terms of what is written there came from this point, which is for me very confusing, of the molecular weight. That molecular weight is the one that threw things out.
Let us correct this question. Thank you so much, sir. Let us correct this question. Let us just look at the question at the question again. We see here clearly bromine 58.8 degrees. Do you agree? Ne? And HCl, hydrogen chloride, minus 85. So do you agree this forces must be stronger? It must be stronger. In this case, the London forces must be stronger than the dipole forces. The values show that to us. Are you happy with that, sir? We can't say the dipole is stronger. Now here it's given. Look, there is the relative molecular mass. Okay? Are you happy with that? And you can see how low that molecular mass is. Remember, we are getting technical now, but hydrogen chloride don't only have dipole forces. It also have a component of London forces included. So in this case, it must be the molecular mass that plays the role. Okay, I hope that is clear to you. So in that sense, this memo is then correct. That yes, we've identified the forces, that is one mark. But from, how do I know that the London forces must be stronger? I see it from the values given, the boiling points that was given. That's where I know it must be stronger. Now, the only factor that can make it stronger is the higher molecular mass. So that is correct. And then the last one is correct. So, thanks. I think the answers is perfect, but it's a good example to pay a little bit more attention to. We are sometimes making the mistake of just telling learners randomly that dipole is always stronger than London forces. It is only stronger when the molecular mass is relatively the same. Then you will find that the dipole forces are stronger. But it's possible. I can give you an easy example. Let's take iodide. Iodide has got London forces. I2, it's got London forces. At room temperature, it's a solid. Water has got hydrogen bonds. At room temperature, it's a liquid. So that London forces of iodide must be stronger than the hydrogen bonds of water. And we must be very careful to say it is always that hydrogen bonds are just the strongest. It is under certain comparable conditions. I hope that clears this question to you. So I'm happy to say I think this memorandum for this question is correct. Remember, all molecules have a slightly London force nature, but also in this case of HCl, it will also have the dipoles, which will be the major force there. I hope that is clear. I hope that will help you in terms of that. Okay, thank you for that remark, and let me just clarify this also. I think it's now that we did justice to it. I see there's still one more comment or one hand. I think, or are we done? If there's anybody else, you can come online and just quickly ask your question. I think we're nicely on time. I think I've addressed that last remark already. London forces can be stronger London forces can be stronger than dipole forces. In this case, it's got to do with the molecular mass. We know that there's an influence of the molecular mass. I think I have addressed that one. But please, if you're not feeling happy, get in touch with your subject advisor and let us discuss something even further. Okay, I don't want to go into that comment too much. Let us discuss this further. I will share your remark with the examiner. I personally feel that this answer is correct. Okay, all right. Colleagues, thank you so much.
Dr. Stevens?
Yes, ma'am.
Before you go away, is Madewa Zapi speaking?
Yes.
Could we please remind the teachers to sign the register? It is in the link in the chat.
Oh, yes. Thank you so much. Thank you so much. Colleagues, it's very important that you do sign this register. We could see we were about 50 people at some stage. We got less a little bit later. Please sign the register. Also, your colleagues that's going to look at it later on YouTube, because they might have been invigilating, ask them also to sign the register. It is very important that we get a signed register from you. I see I've got a hand up. Okay, I'll give you a chance to speak. We've got a hand up. Okay, ma'am, let me try and address your issue. Your hand is up, and I saw that you have you will see when you go to grade 12, when you go to organic chemistry, and if you look at let's say the haloalkanes, then they will have a dipole nature as well as London forces nature. Now we don't expect the learners in grade 11 to know that already. Maybe I will need to go and look into the material that we have, like ATPs, CAPS documents, exam guidelines, etc. I agree with you on that issue. But looking at the question, what was given here, the relative molecular mass is standing out. The difference in boiling point shows me that the London forces must be stronger in this case than the dipole forces of the hydrogen chloride. I cannot derive any other thing from the information given that it was the relative molecular mass that is the difference.
Can I
this is the type of question that we do get, that learners can expect to get.
Can I pitch in?
Yes, you can.
Okay, now you got it right when you say the relative molecular mass or atomic mass is the factor. But you are missing it here when you are saying the London forces will be stronger than the dipole. Remember, any molecule that has dipole also has the London forces. So the bonds, intermolecular forces in that molecule should, by merely saying that, be stronger than the one with the London forces, because it doesn't have the dipole. But in this case, we have brought in another player or another variable, which is the molecular mass. So our difference in boiling points is not necessarily on the IMF, but now because this one has heavier molecules, which will be difficult to lift up, because as something boils, we are taking it from liquid and making the particles to be separated and hence be able to move in all directions. So it is just that part where you are saying the London forces are stronger than the dipole. You miss the point that the very molecule that has dipole also has the London forces. So there's no way the intermolecular forces for bromine, because of the type, can be stronger than that one of HCl. The player here, the variable, is actually the molecular mass. Thank you, sir.
Okay, thank you very much. I appreciate your comment there. Okay, colleagues, I think with that said, we still have our marking guideline that we will apply. If we have a problem with the marking guideline, we need to take this then further with the examiner and the moderator. So I will again run this past him, but as it is now, 10.6 stands that we will award the marks as it is shown here. Please accept that. That's not my paper. I'm just applying what they introduced. So, and I don't want to open this even further because we are already over our time. If they feel they want to, you need more discussion, just contact your subject advisor, and between you can make a decision on how you will mark it, and your guideline in your teacher portfolio will show that exactly to whoever is going to moderate you maybe later. That is very important. Okay, colleagues, so with that being said, let us stop that discussion there. We are already over our time, and I'm going to cut out at any second because of my availability of what I have here. I see that there's somebody who's saying that the register link is not opening. If that is the case, then we will make sure that we send the register through our subject advisors to you on your WhatsApp groups, and you can fill it in from there. Thank you for that comment. I really appreciate that. Okay, colleagues, thank you very much. Much appreciated.